Hi everyone, I'm Tim Kington and this is Coding is for the Birds. Daisy and I have decided to tackle a large project. We're trying to build a Java virtual machine. And in part one, we read through the class file for a very simple program and managed to at least process all of the pieces. Today we're going to try to figure out how all those pieces fit together. So last time we read through all the pieces of this file, but we didn't keep any of the data around anywhere. We just logged a bunch of things. One thing that we're going to want to do is keep this constant pool around. So I think I'm going to create a package for our model classes, and then I guess we'll create an interface maybe for a constant. And we'll store a map of these. So I guess it's not a map. I think it's just indexed by number. So let's make it a list. Did it import the right? Okay, we got the right constant. So now, whenever we read a constant, I'll put it into our array list. And that means this needs to return a constant. And we've got to fix these cases. So this one will be a constant string. So we have string constant here. Means we need a new type for that. It's going to have a string in it. I think I'm going to make these things public just for ease of use, and we'll see if it's worth making anything private later on. Here we're going to return a new string constant with our string. And so this needs a constructor. All right. I need to return a class constant. I guess we'll just add the types and worry about the data later, right? We need a method ref one and a name and type. So back here, why isn't this working? We just needed the imports, I think. Okay, this is a method of constant. And this is a name type. right. So we've got that. Now we should be populating our constant table as we go. Now that should be, okay, it's a member of our class. It's getting populated. All right, I took a little detour there and tried to wire up some of these indices, but it turns out that the indices are seen before the constants are defined. So for example, this might reference class that is constant number 9, and we haven't gotten to that constant yet. So I'm going to change this to just store the indices for now, and then we will associate things later through the constant table. So let's go ahead and populate these then. A method ref has a class index and a name and type index. And let's give this a constructor. These are in the right order, right? Okay. And then a name and type constant has a name index and a descriptor index. So let's put those in there. Name descriptor. Okay. And then method info, we're going to have a name index. And then we have a descriptor index. Oh, I just called it the wrong thing. Okay. So we're going to copy this basically for our method ref. Oh, wait a minute. This is method info, not the constant. Right, this is the actual method, so we need a type for that as well. I don't think this is going to work, is it? There's already a method in the java.reflect package, so I was not really expecting this to work. I guess it'll work for now until we have to do something in that package or use that package. So this needs to be returning a method object. And right now we're not doing anything with the attributes, but I'm sure we will soon. And where this is called, we need to, I guess, keep a list of these. So here, that to a list. So we're reading our constants, we're reading our methods. Now I guess at the end here, we could dump the info that we've read. So I think I'm just going to add a toString to these. No, we won't use println. We'll have a dump method. So we'll say method.dump, and we'll pass in constants as a parameter. constant. And we're going to print something useful, method. And then we'll print the name, which will be constants.get name index. Descriptor? I'm not sure what descriptor is going to be. This will be interesting to see what it actually is. I think everything's compiling right now. So maybe we should go ahead and run this and see what happens on live view. Okay, so this has a descriptor for code and a descriptor for args now. This is a little weird. It's making me think we didn't do the descriptor part right. Yeah, we're definitely off here. I think the constants table indices are starting at 1. I bet that's what's going on. What happens if I do this? Okay, now we're talking. All right, so our first method's called init, which is a constructor. Its descriptor is empty parentheses v, which means it takes no parameters and returns void. And then our main method takes an array of string and returns void. Okay, so this part's working. Now, we'd also like to figure out the attributes in the method. Now, this is something we didn't really dig into last time. We read through the attributes, but we didn't look at what was inside them at all. In any case, here we're going to need a list of attributes. And we're going to need an attribute class over here. And then read attribute will return 1. Need to import the right attribute here. Okay. And now we've got to figure out what's going on with our attributes. So we've read the data, but I think what we really need to do is go back and take a look at what these things really are. So the attribute name index goes into the constant pool. The attribute length tells us how much data there is, and then we have data. And then, based on the attribute type, oh, we have a lot more structure to worry about here, don't we? Okay, so let's go ahead and print out those attribute names as we encounter them. Now this should always be string constant when we look it up. So let's say this. We can return null just to make this compile. And let's see if this works. It's possible. Okay, so we have a code attribute and a source file attribute. So let's go ahead and handle these then. I don't know what, it's weird that adder length is after the name. I wonder if we're really going to need that. Anyway, let's do code. So code was one of our cases. What is wrong here? Ah, yeah, we have to assume this is a string constant. Okay, if it's code, we'll do something. If it's something we don't know about, we need to throw an exception. Okay, and then let's look at the code attribute. So we need to handle this. Guess we'll say return. Okay, so we're going to need a bunch of stuff here. Exception table, okay, attribute count. So it's kind of weird that we have this attribute length at all because we don't need it the way we're going to read this. Anyway, we need a code attribute class, so let's create that. I guess attribute's an interface, maybe. We're going to have to figure these things out. The constant and attribute interfaces, we don't know what we're going to do with them when the code's actually running yet. So I'm just creating them so that we can make lists of different types of constants and different types of attributes. Code attribute needs this stuff. You know, I guess really we should probably be doing this in the class. Let's do it this way. We'll say new code attribute, and we'll give it in. This is what we really need to read. And these have already been consumed. Well, we can leave them there, but we don't need to read those. So we're going to have a public short max stack. We're going to have public short max locals. Public int code length. Actually, we might not need to keep that around. We'll have a public byte array code. We're going to have a public exception entry array, exception table. And then we're going to have some attributes. All right, we need a new class exception entry. That's fine. These things exist, so now let's read them in. Oh, we can't easily read them in, huh? I think for better design, we want to rearrange this a bit. We probably want to pass the parser. I think this is okay. The parser is in the default package right now, so I don't think it's going to be able to see that, right? So we probably need to put it, it could probably go in model, I guess. I meant this. And then code attribute can use the parser, so we should be able to read the attributes here, right? So let's try that. Yeah, great. Read you two. Oh yeah, we decided we didn't need that. Code equals new. Right, so. And now we read the code. Log that. We have an exception table length. I guess we don't need to log this either, really. If this is not 0, we'll throw an exception, maybe. We're not going to handle exceptions right now, so. But it's nice to notice that when we write some code that does cause an exception thing to happen. And now we'll get the number of attributes. Code adder count, I guess. And then so something like this, right? Now back here, we were doing this, but we're not going to do this anymore because each type of attribute will go ahead and consume the rest of its body. So that's fine, I think. Let's go ahead and run this and see if the code piece executes. Code length 10,001 doesn't really seem right. I don't think max stack is probably right either. What is wrong here? We did not consume attribute length, which is going to be there for every type of attribute. So let's throw that away. 4, yeah. Okay, that's more like it. So we got attribute name index was 7, the length was 2f. Then we read max stack, max locals, code length. This stuff all looks pretty reasonable. And then there are 6 attributes for the code attribute. And the first one's line number table, and then that exploded because we don't know how to handle that. All right. That makes sense so far. We should probably change this log, this adder name index. That's in parser. Adder name index. We probably want to log this instead. So this could be null. And then And this shouldn't be string const. This is adder name, actually. Okay, so am I going to log that null? Did I check for nulls in? I don't think I'm actually handling the nulls separately in all these places. Let's make sure those are in there. Yeah, I didn't do this. All three of these, but I'm going to want to eventually. Okay, so we're getting to line number table. Now it says attribute code, and then it shows the attributes for that, or the fields for that. And then we're trying to do line number table. All right, good. Next up, line number table. That looks like this. So let's make a class for that. So we have a line number table. Each entry is going to be starting PC and line number. We want a list of those. I want to make line number a separate type. Probably. And it has in it start PC and line number. Are they ints, I guess? They're shorts. Constructor. U2, yes. These are both U2s. That should do the trick for that. Right. Okay, local variable tables next. Maybe we should add attribute to each of these names. I guess we're going to have to make them all implement the interface too as we go. I've probably forgotten some of them. All right, local variable table. And this is going to have a list of local variables. We're going to probably want to refactor some of this stuff. Later, but for now, I'm just going to get it all read in. This is going to have these fields. I guess these shouldn't really be named this way. I guess we want name and descriptor to be strings, probably. What's index? Okay, that's the index of the local variable. All right, so name and descriptor probably get converted to string. Let's go ahead and make them strings, I guess. So read a short, and we'll go ahead and still log these for now. That's null, and then name equals. I need a way to get to the constant table here, so make this public. Continuing with our bad design choices in terms of encapsulation, I'm going to do that. So I suppose I could do this all in one line. Oh yeah. Name equals const value. And then do this again. So this is going to be descriptor. Okay, and then index. Okay, so that's a local variable entry. This needs to handle those. So need a list to hold these. This has to throw an exception. I think we're back to compiling code here. Okay, local variable table. We still don't have an entry here for that. That thing. Maybe this should be renamed. Let's rename this. We might want to change that later, but for now it'll help us remember those came from attributes in case we run into another thing like that. All right, source file is next. Let's check these local variables. So we have two local variables. Start PC. That's interesting. So this must be where their scope begins, the starting PC. We have a length. So that's the scope, I guess. And the index is 0, index is 1. We didn't wind up printing those names out. I'd kind of like to see those. Let's... Should at least be able to get the names of these variables and see what they are. Okay, so we got args, which is an array of string. We got x, which is an integer. Cool. And then we blew up because we need to handle source file next. Source file attribute is just a source file name, I guess. I guess I don't care about name index, do I? That name equals, and then print. Hey, we got to the end. Okay, so what were we doing now? We got to the end of the file. What we had done is added this method.dump at the end of our parser constructor. So we were able to dump out the information about our methods. So there are a few things we should do. One is this folder's getting a little wild. Let's create an attribute package. My line number, local variable entry, exception entry, we're all part of that as well. Code attribute needs to go up there. Okay, and then what are our problems? No, that's just because parser, we just need to make some things public. Okay. Read attribute. All right. That's good. The other refactoring thing we wanted to do, I think, is move this code into the method class. So instead of read method info, here we want to say new method and pass the parser in the way we did in the attribute classes that we just did. These won't be here anymore because we'll look those up. All right. So let's create some variables here. We're going to have a string name, we're going to have a string descriptor, and we're going to have a list of attributes. Why is it my choice that's in my project is way down the list here? Okay, so let's do that. This will have to throw exception. Name index is fine. Actually, string constant of parser.constants.get this. And the name equals that. And we're going to do the same thing for descriptor. Oh, and this is, that's fine, I guess. But this we don't really want to log anymore, probably. This is gone. This is becoming descriptor. Okay, and then our attribute count is fine. These are being logged well enough now that I think we get rid of this message. We're going to go through and create our attributes. This is going to be parser.read attribute. Now when we dump our method, I think we're not going to go with this dump plan. What if we didn't dump things at the end? Yeah, maybe it's better to do this as we read it in for now. I'm not sure it's worth writing a bunch of dump methods. So here we got our name. That's probably fine. So we have method main, there's our descriptor, we've got attr_len, which we probably don't need to see. We have a code attribute, with a bunch of stuff inside of there. Let's get rid of attr_len. That's just noise in our output right now. Line number table. Len is fine, local variable len. Got the details of the variables. That's actually interesting, I think. Oh, this should have been null. Let's see the output without all those attr_lens in there. That'll be nicer. Source file index. I don't think we really want to see that anywhere. This is just an index into our constant table. All right, so we're still dumping a bunch of garbage about our constants, which I don't really care that much about that. We've got our constants. We're getting our attributes. We got our methods. This is really coming along. All right, well, it turns out there was a lot more parsing to do there to handle those attributes than I expected. But now I think we're reading in all of the pieces of the file that we need to execute our extremely simple program. We definitely need to handle exceptions and fields and things like that once our programs get a bit more complicated. I think for this one, we really only need the code segment that we got as part of that code attribute. So we should be good to execute some code next time. Don't forget to like and subscribe.